the learning outcome I'm doing is identifying and describing the structural components of the brain that are involved with control of movement. So the brain consists of four structures that are used for movement, and that is the cerebrum, diencephalon, the cerebellum, and the brainstem. So first, the cerebrum. It consists of two is divided into two halves, the right and left hemisphere, and they're covered by a gray matter known as the cerebral cortex, which has four areas that are vital to movement control. And one of these areas is called the primary motor cortex, and that is important for the initiation or beginning of a movement, and coordination of fine motor skills like playing the piano. And the second area is premotor area, and this is for arranging movements before they are initiated, and for rhythmic coordination during movement, and enabling transitions for sequential movement. And next would be the supplementary motor area, and this area manages the sequential movements and structuring of movements. And the last area of the of the cerebral cortex is the parietal lobe, and that directs the voluntary movement that is vital to visual and auditory selective attention, and it's for visually tracking a target, like in basketball, where you get to track the hoop or the people that you have to pass to. And the next brain area would be the diencephalon, and the diencephalon consists of two groups of nuclei, of which are the thalamus and the hypothalamus. So the thalamus is it manages attention and mood, and the hypothalamus manages the endocrine system and the balancing of homeostasis. Next, another area is the cerebellum, and this is important for having smooth and accurate movements. And lastly is the brainstem. It has three areas, which are called the pons, medulla, and reticular formation. So the pons direct body functions like chewing and swallowing. The medulla is a regulatory agent for physiological processes like respiration. And the reticular formation combines sensory and motor and neural impulses that influences skeletal muscle activity.